Alright, so calculus, we are on a chapter 8 practice test. So I'll give you a little bitty overview and then you can tell me if you need some details. 1 through 7 is all from the 8.1 lesson where we had like 7 different tricks. So one's trick is pick a U. Make sure anytime you pick a U that you find the du and then make all the trades that you need to make. Answer is going to be 2 and then the same root you have, and then everybody pretty much is going to have a plus c for a while. 2, the trick is to factor by completing the square, and it turns into an inverse trig problem. We did that in chapter 6. We did it again in 8.1. It's going to be inverse sine. Fraction will have x minus 5 on top of 5. 3, the trick is a combination of algebra and trig. You FOIL it out. You'll get a sine squared plus a cosine squared, which makes 1. You're also going to get a 2 sine x cosine x that makes something. What does that make? Anybody? It's 2 sine x cosine x.
Isn't it on the card?
Might be. Might be newly added.
Sine 2x?
It is sine 2x. Then we do antiderivatives. It's going to get final answer x minus half cosine 2x. 4, what's the trick on 4? Divide bottom into top. If the top's power of x is higher or equal, you have to divide bottom into top. Then you go at it. The quotient gets you, once you do the antiderivative, a half x squared plus an x. Minus the remainder gets you an ln problem, minus 1/4 ln, and then in bars the bottom we started with. 5, you want to separate the one fraction into 2. 6x on top of one, 5 on top of the other. The bottom is the same for both fractions, and then that's 2 different types, both of which are on your card. One's an ln and one's an inverse tan. Answer there will be 3 ln 1 plus x squared in parentheses, not bars needed because you know that's positive, and then plus 5 inverse tan x. And again, they all said plus c. Anybody need any more than what I gave you on the front page?
What did you have to do on 5 again?
5, you separate that into 2 fractions. 6x on top of the one fraction, 5 on top of the other fraction. The bottom that I gave you, you keep it the same on both. And then that's 2 different problem types on your card. Basically, if you see a fraction integral, it's either an ln, which one of those is, an inverse trig, which is one of them, or pick a u. That's really your only 3 options. More stuff, front 5. 6, you'd multiply the bottom by the conjugate, go 1 minus cosine on the bottom, and therefore you have to multiply 1 minus cosine on the top. That's going to lead you through some foiling and trig moves, including separating it into 2 fractions at some point fairly late in the process, right before you do the antiderivatives. The antiderivatives are both on your card. The final answer will be negative cotan x plus cosecant x, and as I said, plus c down the line. 7 should be just straight out on your card. If it isn't yet, go back and look at the end of 8.1. They gave you an integral of secant, and probably the integral of cosecant is probably on there also. But this one's 1/10 ln, and then in bars secant 10x plus tan 10x. And I'll pause there. That's all from 8.1 back in the day. 7. 8 is integration by parts. 8, I would do a subgrouping of that lesson called tabular integration, where we built 2 stacks. One stack we did the derivatives down to 0. The other stack we did antiderivatives. And then we paired them off with some adjustments on some signs, positive, negative. But total answer there is negative t to the 3rd cosine t plus 3t squared sine t plus 6t cosine t minus 6 sine t plus c. 9 is a more standard problem. You want to pick the u to be a derivative that's not bad, so that's going to be the inverse trig thing. You're going to pick a dv to be not a bad integral, which the 2x isn't, and then you follow a format. It's going to be x squared tan x minus, and then you get a new integral. The new integral you can't immediately do unless you divide the bottom into the top. The new integral on 9 is going to have an x squared bottom and an x squared top, and you'll have to divide it a lot like we did number 4. The total answer will be x squared inverse tan x, which I already said, minus an x plus a regular inverse tan of x. 10, you only have one thing to choose from, so you make it be u, because you'd rather do the derivative of that ln to make a fraction. So then the dv is what, secret? 1. And then you go at it, not a bad problem. It's x ln x minus x plus c. 11, like 8, is tabular. It's x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Something to 11.
What was 10?
X ln x minus x plus c. More? 12 is integration by parts. It's going to run a loop, and you're going to end up having to combine like terms, and you get 2 of the original problem, so the answer gets divided by 2. It's going to be negative e to the x cosine x plus e to the x sine x, all on the top, a 2 on the bottom. Doesn't matter how you do that with your choices. I picked u to be e to the x, and I picked dv to be sine x. If you want it to be easier to talk to me about step by step how to do that, make the same picks. But if you picked in reverse, that should still work. I just don't have that path written at all on my paper. 13, we're taking a break from integrals, and all I'm asking you to do is rewrite this into 2 fractions and then just stop. So we're not worried about doing any integrals on this. There's enough integrals to do on other portions of this test. 13, I got a 4 and a 3 is the magic numbers, but the full answer I wanted in fraction form. 4 on top of an x plus 2, adding a 3 on top of an x plus 5. 14, if you got a negative 2 and a positive 3, you're in good shape. I have negative 2 on top of x plus 3 on top of x plus 5. 15 should get you a 5 and a 4. 5 is on top of x plus 3, adding a 4 on top of x plus 3 squared. 16, you have 3 things to try to find, and it's conveniently a 3, a 4, and a 5. Answer will be 3x plus 4 on top of x squared plus 1 plus a 5 on top of an x plus 2. Need me to do some stuff with that. We're up, the
16.
group up to 12, that was all from 8.2. This group is now from 8.3, which was page 527.
16.
So you do one fraction with x squared plus 1 on the bottom, one
Yeah.
fraction with x plus 2 on the bottom.
Yeah.
On top of the x squared plus 1, I put an ax plus b.
AX plus B?
Yes. Because if the bottom has an x squared, the top might have an x, might have a number, might have both. So we
Okay.
need to set it up with both.
I should be good then.
Okay.
To figure that out.
All right.
I just wasn't sure where to start with that one.
Yep.
Because I knew with the x squared, like something happened, but I couldn't remember what it
Yeah,
was.
since the top has to have smaller powers than the bottom, it could be hiding an x thing or a number thing or both. So you have to seek them both. If it doesn't actually
Yeah.
have both, it'll show up as a 0 and it'll still be all right.
Yeah.
More to 16? Anything? 17 is from 8.4, which is working from page 533's. So this is the ones with the trig substitutions. I did one of each type. 17, you want x to be secant. So dx is secant tangent. If you do the substitutions and cancellations right, the integral you're doing is just the integral of cosine. So if you want to jot down that the integral of cosine should appear like about 75% of the way into the process. If you get the integral of cosine, you've arrived in a good place. And if you don't get there, don't keep moving forward because you're not on a good road. Final answer will be the root that we started with on top of an x. And the plus c is back. 18, the x is 3 sine. The dx is 3 cosine. Once you do all the trades and substitutions and cancellations, you should get the integral of cotan squared is a pretty good place to be. So if you want to jot down the integral of cotan squared as a goal, that'd be nice. Unfortunately, that's not on your card, but does anybody know how you can finagle your way out of having the integral of cotan squared?
Cosecant squared minus 1.
Yeah, there's stuff with cosecant squareds and ones. There's a property that's on your card from Trig, like the Pythagorean properties, in the same family as sine squared plus cosine squared equals 1. Cotan squared can be traded for cosecant squared minus 1. Then the problem becomes doable. It's going to be negative fraction that you started with, just with an x on the bottom, minus inverse sine of a fraction x over 3. 19 is the meanest one because you're not allowed to have that 9 in front of the x squared. So you have to divide under the root by 9, which makes the 1 a 1/9. And then you have to divide the top by 3 because the root of 9 is 3. And then do your substitutions. X is going to be 1/3 times tan. Dx is 1/3 times secant squared. And the place you want to arrive if you're doing things right, once you substitute and cancel, you'll have the integral of secant. Integral of secant is recently added to your card. We talked about that when we did number 7. So in 8.1, there was integral of secant went on our note card. And then we can just do that up. It's the ln, and then in bars, stuff that would have 1s on the bottom of the fractions, so I just didn't write that. I just wrote the root that I started with plus a 3x in bars. All of that's in bars. Root thing that we started with plus 3x in bars, ln of that. And then pause in there. That's, I think, the hardest page. I once had somebody that had gone years without missing a homework, and they were in 12th grade, and they got to that one and just said, like, I don't need another lunch, I'm out. And they, like, boycotted the page 533s, just took the L on those because they just didn't have the juice to do another thing.
What was 18?
18 was negative, and then the fraction that you started with, just with an x on the bottom instead of an x squared,
Okay.
minus inverse sine of a fraction x over 3.
What was 19?
19 was ln, and then in bars, the root that you started with plus 3x. Order 19.
How do you do 18?
18. So, did you recognize to do x equals 3 sine?
No.
Okay. If it's, then check, do you have that laid out on your card yet?
I do,
Okay.
but I don't understand this
Okay.
like section at all.
Let's find the section just so we can talk. Anybody need something while he's hunting his card down?
Use my card.
That'll slow you down. That'll slow the process down.
It might be in my book.
Anything
Yeah.
we need? 19, got it?
What's in my book?
Alright. So, since that problem type has subtract and the number is first,
Yeah.
that's going to go x equals 3 sine theta.
Okay.
You with that?
Yeah.
Then find dx while that's fresh on your mind. That's 3 cosine theta.
Wait, what?
Dx would be 3 cosine theta.
Okay.
So then on that card, there's a note like, problem was this, problem becomes that. what the problem would become, the piece that's under that root would become like a squared cosine squared.
Okay.
You see that on the card?
Yeah.
So under the root, you'd have a 9 cosine squared.
Okay. So it's now 9 cosine squared under a root
Correct.
over x squared.
Yeah, but we're going to trade that out also. We're going to trade everything out. So like the under the root, 9 cosine squared, yes. Which while we're thinking about that, let's just do the root and have 3 cosine.
Okay.
Next to that, there's a dx,
Yeah.
which we decided 2 minutes or so ago is also 3 cosine.
So
So just write another one of those.
it's 9 cosine squared.
Can be, sure. On the bottom, we need to take the x that we picked about 2.5 minutes ago and square it,
The x.
the x. Because
So it's 9 sine squared.
on the bottom, yes. And then you just clean that all up. So 3 times 3 was 9. That can cancel this new 9. Cosine times cosine is cosine squared. On top of sine squared, that's all cotan squared. So our new and improved, much better integral is the integral of cotan squared.
Okay.
You with that?
Yeah.
Then we'd hope that we have cotan squared on our card, integral of cotan squared, but we don't. Okay, we have the integral of the other trig stuff, kind of like that, but not that. But we do, hopefully you do, have on your card a category where like 1 plus cotan squared equals cosecant squared, something like that.
Yeah.
So if you reshuffle that, cotan squared would equal cosecant squared minus 1.
Okay.
So the integral that we're gonna do is the integral of cosecant squared minus 1.
Okay.
Integral of cosecant squared is on the card as negative cotan. Have that on there. Integral of cosecant squared is negative cotan.
I don't see that. Wait. Negative cotan?
Yeah.
Yeah.
Okay. So we're using that.
Okay.
And then the minus 1 just turns into a minus theta. And then we're 1 switch away. Okay to there?
Yeah.
Then back to the note card where we came in. There's on the note card a note for this lesson, like draw this picture.
Yeah.
So you would draw a picture where 3 is the hypotenuse, the x is the vertical leg,
Okay.
and then the root we started with is the bottom side of the triangle's
Yeah.
leg. So we're gonna then do like Oscar has a heap of apples kind of stuff. And I'd mark the angle in the corner like opposite the x, that's the angle who decides like the x is the opposite, the root is the adjacent, the 3 is the hypotenuse. So cotan is gonna
9
be
minus
the
x squared.
root on the x
Yeah.
minus theta itself is an angle, so we can do inverse anybody. I chose to do inverse sine because
Okay.
that's x over 3. But I could have done inverse whatever. I just didn't feel like writing the root.
So it's just minus inverse sine.
Minus inverse sine of x over 3. But I could have done minus inverse cosine root over 3. I could have done minus inverse tan x over root. Like I just have to pick
Okay.
any trig function that I feel like doing. Should we try to run that back?
Yeah.
Where did we go off track?
Like, what with the inverse sine? Like what?
Theta is an angle,
Okay.
so for trig to give us an angle, we have to do inverse anybody.
Okay.
So I just did, I decided to use the x and the 3 because those are like easier to write, and that x and 3 make sine. so inverse sine,
Okay.
x over 3. If it's saying cotan, like the 1p, if it says sine, cosine, tangent, any of those 6 words in the answer, you're gonna like use that Oscar has a heap of apples to get the fraction the problem dictated.
Okay.
But if it just says theta, theta's an angle, you have to pick which trig function you feel like working through, and any of them can work.
Okay.
More than 19, anybody, anything? Last page should be by far the easiest page, so number 20, anybody have a theory on which number got used?
96.
It is 96, so that's x inverse sine 4x plus 1/4 root 1 minus 16x squared with the plus c in play. 21, anybody?
104.
Is 104. That'll be e to the 5x on top of 25, and then in parentheses 5x minus 1. 22, anybody?
63.
Is 63. It's negative cosine 8x on top of 16. 23 is a double decker. It starts using number
86.
86, and then it'll reduce down and turn into either something that is accessible on your card or is number 82. Doesn't really matter to me. But it'll be tan squared x over 2 minus ln, and then in bars secant x. And then the last one
48.
is 48. It's x minus 5 on top of 2 times the root we came in on, plus 25 over 2, inverse sine fraction with x minus 5 on top of 5. And again, everything there plus c.
What was
20
20?
is was number 96, and it was x inverse sine 4x plus a 4th root 1 minus 16x squared. Anything else I can do for you? All right, so shut that on down.